kind of the age of internet and democracy has arrived. In 2008, we had record-breaking online donations via the internet, and the ability for people to express themselves politically online is greater now than ever. However, and so in the academia, there's been a large amount of research and literature on this topic. However, really collaborative democracy, the idea of citizens involving themselves in the policy-making process is fairly new, at least on the internet. And so, if you look at the literature, you'll find that really there's no collaboration between AI and electronic democracy or collaborative democracy, which doesn't make sense because AI has been well-researched field and it can offer many algorithms and methods to deal with the kind of complex problems that exist in a collaborative, society scale democracy. So another quick, more current motivation. If you've been following news, there's been a lot of turmoil in the Middle East, North Africa, and a lot of the people in the media are calling this the Facebook revolution. Well, in reality, if you look at the Egyptian protesters' manual, it says multiple times, do not use Facebook or Twitter. And the reason for that is because in the past, the regime had taken people who had expressed dissent on Facebook and used that as a tool to identify who they are, who the organizers are, and round them up and arrest them. And so, and they also, any information or photos or whatever was being linked to the regime. So these kind of social networking tools are really good for getting information out, but they're not very secure, and they don't offer somebody who's trying to organize in a collaborative manner a very good platform for doing that. And so, another problem with democratic discourse online is that it's currently under assault by both corporations and even the U.S. military. So they operate these soft puppet operations, and basically that means that you have one person that controls 10, 20 personalities on the internet, individual personas that they utilize to flood a forum or a common thread with, information that pushes their agenda, essentially. And they also use it on social media websites, which have voting mechanisms. They exploit those voting mechanisms to push their content kind of at the top of the rank. And they can do this to make money or to push an agenda, whatever. And actually, interestingly enough, I took this image from the 6th Contracting Division of the U.S. Air Force. And when they were citing or tendering contracts for persona management software to do just this. So, with democratic discourse under attack, I developed something called open assembly. And basically, the idea is that we want to take all these collaborative democratic tools, put them together in one kind of framework that's secure and has these kind of AI mechanisms to help you. So to begin, it's open source, obviously. That's very important because it's already been developed by multiple people across the country that I've never even met. And I think that kind of collaboration is important, not only in the expression of the software, but also its development. And so it's a non-relational backend. And why is that? Because we can use Google App, which is a free server software, which means that organizations can deploy this software in literally 5 minutes. And that means that you can pretty quickly roll your own collaborative organization software for your own organization. It's kind of for whatever means you see it. And to kind of modify it for your organization, it should be easy, to change, pull features out, put new features in. And so we have a pretty abstract architecture. Now at this bottom, you see these templates here, which are like HTML and CSS templates. They're pretty low-level code. So since we've exposed all of our framework information through these template tags right here, in the template language, which is very simple, we're just getting basically an object in the database that based on some ID, and then we have interest, which is how interested people are in that object. And that's it. So when a web designer comes, they can, without any knowledge of the back end or Python or Google App Engine, they can take these template tags and roll their own software framework for collaborative organization. All right, so moving on pretty quickly. This is some screenshots of the currently in work projects. So basically, you create different kinds of content. You can have different kinds of topics. You have a headline for your problem, and you have a description that other people can then read. So that's all fairly simple. And so once you've created some content, other people can then go and interact with your content. They can go and they can vote and say how much they agree or disagree with your content. They can say how much objectively the rating quality of your content. Now this is a subjective factor, this is my opinion, and this should be an objective factor, and people will be told. You can flag content with logical fallacies. So many times on the internet, people will use logical fallacies in argumentation, and it's very hard to point that out. But this way, you just click a button, and then other people can agree or disagree with you. And so we have like tags and sources, and you can also add yes or no arguments for your content. So all this brings together a structured kind of form. And then using the voting and rating that people would execute on these objects, we can create these ranked lists of content. And now this is kind of the part where a malicious actor would want to come in, because you have a ranked list of content, either arguments or problems or policies that people have collaboratively created. You'll have someone want to come in and manipulate this, but their agenda is at the top. And so how do we stop that? So that's where the research part comes in. And we're working in a reputation system and trust network research. So reputation systems essentially try to protect the network from malicious actors or sock puppet accounts. And so each user is tied to a global reputation score. It kind of gives the community an idea of how reputable they are. And so essentially the objective of the system is just to reward good users and punish bad users. And our approach, more formally, we're taking multidimensional adaptive vote flow approach. So what we want to do is change, we want the votes to flow through the trust network based on these reputation dimensions. And when I say dimension, I'll get to that next. So what would be a dimension of reputation? Now, it could be like somebody's content. So that once you create content, other people will go and vote on them. And once other people vote on your content, if you're consistently being rated as a high-quality content creator, you should have a fairly higher reputation. And also, you can have people subscribe to your content within the system. It does have social networking features, so you'll have the ability to subscribe to others' content, and that'll be part. And also, you can confirm that they went or attended some event, for instance. And there's also other ways to rate trust. And so the rating task capability is also another interesting way to determine someone's reputation. Now, if you have any objective tasks within the system, such as the objective quality task, which there should be some objective quality for each piece of content. If someone's consistently rating, somewhere close to the mean of the rest of the community, we could say that they have a fairly good rating task capability. If they're consistently rating far, as an outlier, we could say that the rating capability probably isn't that good. And so there's another kind of method, reputation dimension, that we've developed for this system and what will be tested on. So essentially, it's very similar to photo tagging, but it's a little bit different. So basically, two users would take a photograph either through a webcam application on the website, or they could simply upload one that they took themselves. And both users would confirm that that was their photo by logging in separately to their account at a different time and confirming that. And so what this does is this forms an explicit link in the trust network. So we know that there's a photo of these two people. They've been together before. They've more than likely they have a real connection in real life. And that's important because we want to connect real life events, real life collaborative democracy with an online activism. So that's very important. So, but really, somebody could probably fake this. So how do they prevent people from faking? And so we have the randomized anonymous voter verification, which is an attempt to help people prevent people from faking them. So essentially, you have a set of photos, and you will. This is a highly reputed member of the society, so they have a pretty high reputation. So they click on a photo verification task, and they get a set of photos of another user from somewhere else geographically. And you don't choose what set of users, it's random. And it's also anonymous, so it's just a set of photos. And so all you do is you say, okay, is there a common single person in each of these photos, yes or no? And so if you do this over multiple times, you pretty well verify that these photos are probably legit. And so now we've taken what was just a matter of creating an account, maybe entering a CAPTCHA, and now the sock puppets, they have to find, a dozen people to go out and photograph with them in order to kind of break the system. And so that's gonna really, really up the difficulty of trying to manipulate this kind of system. And so the other kind of research that we're doing, jumping to a different point real quick, is AI personalized agents. So we do a lot of multi-agent work here at ATU. And essentially what I'm developing for this system is your personalized agent. And in reality, you can think of it as just like your political representative. So this agent represents your beliefs in the system. So once the agent can learn to predict how you vote by creating a mathematical model of your beliefs, it can then unofficially represent you in the community, essentially. So this can be useful for things such as, unofficial polling. Someone could create content, and rather than polling every individual, requiring them to manually vote on something, simply the agents would report what they believe that person would vote. And therefore, you have kind of an unofficial idea of how the community would react to that content. All right, and so there's other kind of interesting advantages once you've formulated someone's political interests into a mathematical model. So you can do things like create these dynamic coalitions. So given some number of users you want to join together, some subset, you can identify which users have very strong similar preferences and who might be very interested in working together, but they may not know each other. So you could have two people from across the country that are working on very similar goals that have never met each other and don't know about each other's work and could very easily collaborate together, but they don't know each other. So that's what the agents come in. They can find people in the system you could never find manually. And they can also do things, so you probably heard of a platform or a manifesto, like a party platform. They have a list of ideas that are trying to, basically their core values that they want to get out to the public. And so once political preferences are a mathematical model, this becomes an optimization problem rather than, this big parliamentary process of voting and submitting new policies, new planks. Instead, now let's simply optimize across the space of, all possible policies, trying to maximally satisfy all possible users. And so that's a problem that, has been studied very well in AI optimization. So you can take all those methods that have been used there and apply them here. And so it can do other things like proxy voting, which is pretty simple. And so basically, we're going to deploy OpenAssembly, employ stage sock puppet attacks, and multi-agent simulations to kind of validate the reputation and basically to evaluate the AI agent, we simply need to show that they can predict how people will vote. And so there will also be some subjective evaluations, such as how do people feel about the coalitions? Do they trust the agent to proxy vote, etc. And so that's about it. I described OpenAssembly, and discuss two research